Drones, also known as unmanned aerial vehicles, UAVs, have become increasingly popular over the last decade. These devices have been used for a variety of purposes, including military reconnaissance, wildlife monitoring, and aerial photography. However, the most exciting application of drones is their potential to operate autonomously. Autonomous drones are UAVs that are capable of operating without human intervention, using a combination of sensors, artificial intelligence, and machine learning algorithms. The opportunities presented by autonomous drones are enormous. They could be used in a variety of industries, such as agriculture, construction, and transportation. For example, drones could be used to survey crops and identify areas that require more water or fertilizer, improving crop yields and reducing waste. Autonomous operations are complex from a technical standpoint. While AI-controlled drones with vision carry all the hype, underneath there are various sensors, controllers, and sensor fusion algorithms working in tandem to achieve autonomous flight and also serving redundancy. Sensors are far from perfect. GPS-aided drones can suffer from loss of GPS signals. Localization and mapping algorithms in GPS-denied or intermittent conditions have limitations based on environment texture, reflectivity, types, and the quality of sensors used. Battery limitations restrict the total duration of the flight and can become a hurdle for automated paths, especially for prosumer category drones with limited payload capacity and flight duration. Loss of battery power in the middle of the flight can cause forced landing in rough areas where recovery of the drone is a challenge. Autonomous drones operating in GPS-denied areas require complex algorithms involving a fusion of sensors such as laser, cameras, inertial measurement unit for localization and mapping, obstacle avoidance, and path planning. Algorithms can fail due to sensor limitations, and this can lead to drones getting lost or colliding. Drones can drift due to strong winds, crash against static obstacles, such as trees, and dynamic obstacles, such as birds. Sensors can fail under different environment conditions. To be able to handle all of these factors is an enormous challenge. Some form of wireless radio beacon signal still remains a necessary requirement to periodically convey where the drone is to the remote monitoring operator. Recovery of a drone that is lost or crashed in especially difficult terrain or dangerous areas is a complicated issue. Adding redundancy in sensors, services also has an impact on cost and operations. Expensive sensors and sensor-based hardware can provide good operation in GPS-denied areas. But drones are always prone to crashes or failures, and more expensive hardware in difficult terrains or conditions has a cost impact. Deep learning with cameras is used extensively in the newer generation of autonomous drones, relying on camera vision for autonomous navigation. But AI remains an empirically tuned black box. The amount of training data necessary to tune the model defeats a number of use cases where it's difficult to fly the drone with pilot manual control to get access to the data. There have been mind-boggling advances in this field and will continue to solve more problems. For remote monitoring of autonomous drones, camera-based video transmission is preferred for first-person view, but also requires high-bandwidth wireless transmission and can have larger latencies based on the connectivity chosen. 4G and 5G connectivity is applicable where the cellular signals remain in range. The Federal Aviation Administration in the US and the equivalent in other regions state that there is a 400 feet altitude flight restriction unless specific permissions are acquired for industrial asset inspection. For drones flying outside line of sight, you must have a spotter that maintains direct line of sight. Flight is restricted within 5 miles of any controlled or uncontrolled airstrip or helipad. There are also restrictions on flying near stadiums, during emergency situations, and flying over people not involved with flight operations. Autonomous drones with secure connectivity to cloud does enable various advantages, such as remote fleet management of multiple drones, flight planning for the entire fleet of drones, pushing software upgrades, deploying new AI models to an already deployed fleet of drones, real-time telemetry, and logging. There is no doubt connected drones, especially for autonomous operations, are going to be extremely useful. Connectivity can vary from cellular, satellite, and other types of wireless. The market for industrial asset and infrastructure inspections is ripe for use of autonomous drones. Whether it's inspection of cell phone towers, wind turbines, electrical transmission towers, windmills, bridges, or oil or gas pipelines, autonomous drones have a huge potential. The agriculture industry is already using GPS-guided drones extensively. Site monitoring, including construction, is another fast-growing area of drone use. Autonomous drones have come a long way in recent years with advancements in autonomous navigation algorithms, onboard compute power, and sensor technology. While there are still challenges to be addressed, such as safety concerns and regulatory issues, the feasibility of autonomous drone operations is rapidly increasing for specific use cases. One area where autonomous drones are being increasingly utilized is in the delivery industry. Companies like Amazon and UPS have been testing autonomous drone deliveries in select areas with promising results. The use of drones for deliveries could revolutionize the logistics industry, reducing delivery times and costs while increasing efficiency. Another promising use case for autonomous drones is in agriculture. Drones equipped with sensors and cameras can provide detailed data on crops, allowing farmers to make more informed decisions about planting, fertilization, and pest control. This can lead to increased yields and reduced waste, ultimately benefiting both the farmers and the environment. In addition, autonomous drones have the potential to be used in search and rescue operations, disaster response, and infrastructure inspection. These applications could significantly improve safety and efficiency in emergency situations, as well as reduce the need for human workers to perform dangerous tasks. However, as the industry moves towards more widespread use of autonomous drones, it will be important to carefully consider and address the potential risks and challenges. This includes developing reliable and effective algorithms, ensuring safety and regulatory compliance, and addressing concerns about job displacement and privacy. By focusing on specific use cases and taking a responsible approach to implementation, the potential benefits of autonomous drones can be realized while minimizing the risks. Thanks for watching this video. If you enjoyed it, please give it a thumbs up and don't forget to subscribe to our channel for more great content. We'd love to hear your thoughts and feedback in the comments below, so be sure to let us know what you think. If you want to stay up to date with all our latest videos, be sure to hit the notification bell and turn on notifications so you never miss a new upload. Thanks again for watching, and we'll see you in the next video.